Okay, so our first lemma in this video is going to be that the function given in the setup of the Noether isomorphism theorem is one-to-one, so that it's a monomorphism. So we've already seen it's a homomorphism. So it remains to show to be a monomorphism that it's one-to-one. So for one-to-one, let's suppose that f of, well, actually let's do something better. We're going to use the fact that you're one-to-one if and only if the kernel of u is 0. We show that the kernel of f is 0. And the 0 in R mod kernel phi is the coset that represents 0, which is 0 plus kernel phi. So let's do exactly that. So suppose that f of R plus kernel phi on the one hand is 0. So R plus kernel phi is in kernel f. I know that's a little bit weird to wrap your head around, but that the elements, the inputs for f look like cosets again. Okay, so by definition of f, this is plug R into phi. So it's saying that phi of R is 0. And this is saying that R is in the kernel of phi. But if you're in the kernel of phi, the coset that represents you is 0. Okay, so the only guys that f sends to 0 are, well, the coset that represents the additive identity. So if you remember the language when we talked about this, we say then, well, I'm not going to say we say, because we've already introduced it, but then the kernel of f we call trivial. So that just means kernel of f only has the additive identity, which is always, always, always there. In particular, that's this statement up here. That's this guy right here. So f is a monomorphism. All right, let's tackle epimorphism now. I put the domain and range for f in the statement just to remind you. I'm not going to do it here. So f is an epimorphism. Proof? Well, we've already seen f is a homomorphism. So we just need to show onto. Okay, so let's do that. Let me just go scroll up for a second here. The codomain of f is the image of phi. So we're going to take some s in the image of phi. Then what does it mean that s is in the image of phi? Well, it means it's an output of phi. Image is just range. Phi goes from r to s. So there exists some r in r such that phi of r is s. That's just the definition of the range. So things that are actually outputs. Well, then f of r plus kernel of phi is equal to phi of r is equal to s. Thus f is onto, because we found an input, namely this guy, that gets sent to the output s, no matter what s in the codomain of f we pick. So our function that's giving us this Noether isomorphism theorem is also onto.